So we had vacuum tubes as the main electronic device, and then we had, for input and output, we had punch cards, right? Punch cards are nothing but we have bunch of numbers, and then you will have punch it like this. Let me open it a separate tab, right? Something similar to this one. Let me have a bigger one. Let's say yes, something like this. Now you'll see here. So this is a cardboard, and then there are numbers from 0 to 9. You will see, and here and there are some holes. So this will, create the punch card. Now early days, for each instruction, remember, each instruction you have to create a card. So that means you have to have a stack of cards as an input. I will show you like some of the videos where they will show you this bunch of cards are used as an input, right? So the second thing you need to remember about the first generation computers, punch cards were used. We have used punch cards, right? And then the languages we have used. Now we know that nowadays we have programming languages like Pascal. You are supposed to learn Pascal programming language in grade 11. But early days we didn't have such languages. What we had was what we call machine languages. Now machine language means nothing but we use machines language. That means if it is an electronic device, that means we will use high voltage and low voltage, or mathematically we can represent ones and zero. Now it's like this. Now let's say nowadays we want to write 1 plus 2. This is how we used to write. But early days, 1 is writing in binary, like that is 1. 2 is again binary, that means 1 0, and plus is so in binary, like 1 0 1 0, something, some patterns of ones and zeros. So when you instructions written like this is called machine language, right? And early days computers were used, especially when you take Babbage's and so on. So those computers, actually you had the binary digits, and nowadays we have simply we can just write 1 plus 2. But earlier we had something like this, and this is called machine language. And then later we people realized that if you put in this form, this is not easy for everyone to make programming, right? So they had what we call the assembly languages. So in assembly we had commands like add, and then we put one command 2. So we have written like this, right? The advantages is now the humans can understand this easier. So this is better than writing commands like this. But it's still computer couldn't understand this one, because what computer understand is a machine language, right? And those computers were very heavy, very large size, like a whole room. It occupied about like very large room, and it consumed a lot of electricity, like electricity for a small city, right? And the computers were very, very expensive. When you take computer ENIAC, the ENIAC is first generation computer, right? So when we talk about the ENIAC, I think we have discussed this earlier as well. The computer ENIAC, so the computer ENIAC is actually based on you will see a couple of images on ENIAC, and this is where we have, you will see it's a very large room, and it consists of 18,000 vacuum tubes. 18,000 vacuum tubes were used to create this one, right? So you see something similar to this, right? And the display is just a set of bulb. I think I shared you with some links last time, isn't it? I have shared with you some links, But ENIAC I didn't show you. Maybe I will share with you. There are some videos on this one. Maybe I can quickly find some for you how ENIAC works. All right. Um, so this is actually movie reel on ENIAC. So this is in YouTube.
In 1946, moviegoers got their first glimpse of an astonishing new machine.
Are people becoming obsolete? A giant electronic brain has started cogitating at the University of Pennsylvania. It's made of vacuum tubes like your radio, and it can add up a column of figures a yard long in a second. It's the world's first electronic computer. Right now, it's solving mathematical problems for the U.S. Army, but who knows? Someday a machine like this may check up on your income tax.
So in this one, what we have seen is some movie reel they have developed for ENIAC, and then the computer actually developed by Pennsylvania University, and people were using it here. So this is the two persons actually responsible for creating the ENIAC computer. And this is the place where you had the large so they were taking out some vacuum tubes. The statistics said there were about like 18,000 vacuum tubes were used to build the computer, right? And then even that it can actually make printout. So what you see here is a printout. So there was a printer, but there's no keyboard, and there's no monitor as well. So we had bunch of lights. You see this, the lights are there, bulbs are there. So, and this was the output, because this is a number crunching machine. They work with the numbers, and here it will display the answer in bulbs. So this is how the monitors looks like. We didn't have monitors at that time, but what we had was a set of bulbs like this, right? So this was the output. And there were there were a lot of ladies actually work. That's what I heard. Like if you see images, you will see there are ladies working with this machine, right? So I don't know whether you have realized there's a lady actually here working with putting bunch of punch cards, right? Let me go quickly back. See here that particular ladies work with a bunch of punch cards. Okay, so I hope you got some idea about like how computers look like in first generation computers. What you need to remember is the main technology used there is vacuum tubes and the punch card as inputs, and machine language and assembly languages were used, and then it generates a lot of energy, heat, large in size, consume a lot of electricity, as well as it's expensive. And examples are ENIAC. Now in second generation computers, I told you it's between 1956 to 1963. Then they have used what we call the transistors, right? So when you look at transistor, actually they are a bit bigger earlier. Now whether we have now these transistors have what we have had nowadays, transistor looks like this, but the size is actually a lot bigger than what you have seen here, right? So it was not very small as such, right? But this is what it used as a main component, right? The transistor. And then punch card is still were used, and tapes and floppy disks, right? Nowadays we have hard disks, right? But earlier we had tapes, right? So the tapes are, I mean, so something like this were used to keep track of data, right? So this is actually one of the old days computer where you use a tape to record that, keep track of data, right? Magnetic tapes like this, right? And then floppy disk. We had floppy disk, right? So when you use floppy disks, uh, something similar to this one. Uh, the storage sizes were very, very small. Now, for example, if you take, this is the latest floppy disk, 3.1 inch floppy disk. And what you can store here is about like 1 megabytes. If you compare like MP3 song you used to hear, to store a MP3 song, you need, 3 floppy disks like this. So you can imagine how small they are. So before hard disk comes in, the floppy disks were used in computers, right? So this is called floppy disk.
Are they used nowadays?
Still we have some of the computers, like if you buy all computers, you will still see the slot for this, and floppy disk are there, but very rare nowadays. Usage is very rare, but still people use. In old machine, they still use floppy disk. Okay, so that's about the floppy disk. Those are for storages. And then from second generation computers, we had high level languages. I told you like 1+2, we can write the way we used to write. So when you develop programs, you were using the same way. So that's why we call high level languages and assembly, right? The size of the computer is smaller compared to first generation computers. It's faster compared to first generation computers, but it's still expensive. Expensive means no general public actually used any second generation computers. It was very expensive, and only organization could afford those. The Honeywell 400 is one of the example. So this is not the computer. Right. So it's something similar to this one. Right. So you see some tapes are here. So tapes were used in to store, but still there was no keyboard or mouse. Right. There was no keyboard or mouse were used. Punch card were used. Still punch card were used. And then the transistors actually used to build the computer. Right. So that's about the second generation computers. Next comes the third generation. We had integrated circuits. Or you can use single chips like this, integrated circuits. So the electronic component is quite similar to this one. So the number of transistors inside were quite large compared to the previous generation. So the main electronic equipment uses integrated circuit, or in short we say ICs. Right, and that time we had high capacity disks. Still there's no hard disk. High capacity disk like zip disk. Right, you could store about 100 megabytes, 200 megabytes, quite large compared to floppy disk, something similar to this one we call zip disks. You can see it's about 100 megabytes you can store, right? We were using zip disk at that time. So that is in third generation computers. And then keyboard and mouse were used. So at that time we had keyboard and mouse and operating system. Early days there was no operating system, main software were not used. Size was small compared to second generation computers, faster compared to second generation computers, and it also generates less power. So if you look at IBM 360, 370 computers are example for this. So let me show you IBM 360. So the computer is something similar to this one, right? Something similar to this. Right? So something similar to this one. So I told you about the keyboard, and this was the keyboard. So this is the tape drive, and this was the keyboard, right? So this is what we have used there to enter anything inside the computer, right? So that's about the third generation computers. And next we have fourth generation computers between 1975 to 1989, right? Then we were using microprocessors, right? So you had 100,000, transistor you could put inside these ICs. Number of ICs were, compared to earlier, it was huge. You can put inside the microprocessor. And nowadays, if you even take the fifth generation computers, we still have microprocessors, but the number of transistors that you can put inside were quite large compared to previous years. So from fourth generation onwards, microprocessors were used, and then the number of transistors that you can put inside were getting large. The technology is used for that is called large scale integrated circuit, or we say LSIC. Right. Or very large scale integrated circuit, or we, in short, we'll say VLSIC. So these are the technologies were used to build microprocessors. And then hard disks were used from here onwards. In fourth generation computers, hard disks were used. And also optical disks like CD-ROM were also used for the storage. And operating systems had graphical user interfaces. Now earlier, in third generation, we had command line interfaces. I think we will discuss the difference in the coming session. But for the time being, remember, OS with the graphical user interface were used in that time. Again, very small computer size, portable, upgradable. Portable means you can take here and there. The early days, it was huge, right? The third generation computer you have seen, you cannot move easy here and there. But from fourth generation, it was quite comfortable. You can portable, you can move here and there. And upgradable means you can improve. You can improve the or increase the memory size, for example, right? So the IBM PC is one of the examples. Something similar to this, right? So you have fourth generation computers were quite similar to this. Monitor is like a TV at that time, and keyboard is also quite large, and floppy disks, you can put it here inside. So that's what we call fourth generation computers, right? And nowadays we have what we call the 5th generation computers, right? So that's from 1989 to present time. Again, microprocessors were the technology we used, and then we have used technology called ultra large scale integration, ULSI, to when you create microprocessor, right? So very high capacity hard disks were used. Internet was there, multimedia applications were there at that time. Artificial intelligence applications were there in 5th generation computers. Portable, less expensive, and high efficient. Like IBM notebook is an example. Book that time, not like in 19, let's say 80, something similar to this. Yes, this was like early days, how IBM notebooks looks like, right? And you will see it here as well. So in this video, actually, you can see how portable computers and laptops are used.
This was the first portable computer, the IBM 5100. Here it's shown powered on and attached to an external monitor. Although weighing 55 pounds, it was much lighter and portable than previous computers. The Xerox Note Taker was a bit more portable, and its keyboard folded out to reveal its screen. It employed what was then highly advanced technology, including 256 kilobytes of RAM and a 5 MHz Intel CPU. Launched in April 1981, the Osborne One is recognized as the first laptop computer. It was the first commercially successful portable computer, costing $1,800, weighing 25 pounds, and shipping with a large bundle of software. Later that year, Epson released a tiny battery-powered portable computer that traded screen size for convenience. It was hailed by Businessweek magazine as the fourth revolution in personal computing.
Taking a computer along with you can create a few problems. Unless it's the new Epson HX20 notebook computer. It does what most computers do, without the power cord. With a built-in screen and printer, you can do real computing and word processing anywhere, at about half the cost.
The Grid Compass was the first portable computer that resembled our current laptops. Because of its high price and specialized application, it was mostly used by the US government. NASA used it on the Space Shuttle during the early 1980s, as it was both powerful and lightweight. And the Special Forces used them for their ruggedness and use of solid-state memory. The TRS-80, sold through Radio Shack, was popular with journalists. They could type about 11 pages of text, and then transmit it for editing, using the built-in modem.
Radio Shack's revolutionary Model 100 computer. It's a word processor, phone directory, and dialer. It even communicates with the office computer.
Fletcher, how's that report?
In 1984, the Commodore SX64 was the first portable computer to feature a full-color display screen. It weighed about 20 pounds and sold for $995. It shipped with 64 kilobytes of RAM and a 1 MHz CPU. It did not sell particularly well, but became popular with user groups and software developers. They could quickly pack and unpack the machine to use for copying software or giving demonstrations. The IBM Pc Convertible was the first laptop to use the 3.5-inch floppy disk format, which went on to become the industry standard. Like modern laptops, it featured power management and the ability to run from batteries.
Presenting the IBM PC Convertible.
A powerful personal computer that easily converts to a full-function portable. One you can use in a train, a plane, a car, or a meeting. And be as productive on the road as you are at the office. The IBM PC Convertible. One computer for people who really need two.
The SLT-286 was the first battery-powered laptop to support an internal hard disk drive and a VGA-compatible LCD screen. It weighed 14 pounds. In 1989, the NEC Ultralight was considered to be the first notebook-style laptop, since it weighed less than 5 pounds. It was priced around $5,000 and shipped with an 8 MHz CPU. After the failure of their first laptop, Apple reworked the concept and released the PowerBook line in October 1991. They immediately caused a stir in the industry, with the dark grey cases and the positioning of the pointing device.
You are about to witness a revolution called PowerBook. It will let you run MS-DOS software. It will let you run Macintosh software. It will let you run away.
In 1992, Olivetti developed and released the first laptop featuring a touchpad. The position near the base of the screen was the norm, as most applications were text-based and did not require a pointing device. That same year, Olivetti released a smaller laptop, the Quaderno, capable of audio recording while the computer was off, an almost instant boot up. It shipped with a 16 MHz CPU, 1 MB of RAM, and 20 MB of hard disk space. The Concerto was the first convertible laptop. It had a detachable keyboard, pen, and touchscreen. But the touch screen only worked with the special pen. Like today's tablets, most of the electronics were housed with the screen. This laptop was definitely ahead of its time. In 2002, the Portage was the thinnest laptop to be developed, at only 3/4 of an inch at the thickest part. It also featured the first 1.8-inch hard drive in a laptop. The TC1100 had a very unique design. It was a hybrid laptop which included a touchscreen, stylus, and tablet mode. Unfortunately, Windows XP was not a touch-friendly OS, hampering its success. Like the Concerto, this was another laptop that was ahead of its time. Asus released the 701 in October 2007, which was the first netbook on the market. It featured a 7-inch screen, an Intel Celeron M processor, and a 4 GB hard disk. The Yoga 13 was one of the first modern hybrid laptops, taking advantage of Windows 8 touch interface. The name Yoga is a reference to the unit's design, which allows 4 different configurations. The Razer Blade was the first true portable gaming laptop. At 0.9 inches thin and weighing 6.5 pounds, the Blade Pro was the most portable 17-inch gaming laptop in its class. The Yoga Book hybrid laptop brought even more functionality in 2016. By using a digitizer panel as the keyboard, the user was able to draw, write, and type on the same panel. The trade-off was the lack of haptic feel and feedback when in keyboard mode. The 2018 version of the Yoga Book now uses e-ink for the keyboard panel. E-ink allows for a more natural drawing surface, and for custom input entry layouts, depending on the application being used. And most importantly, it allows for reading, without wasting any battery, or having to carry a second device. Asus is currently working on Project Precog, which consists of a dual-monitor laptop, similar to the Yoga Book, but without the limitations of e-ink. Both could be used as monitors by connecting an external keyboard. Or both monitors can be used for gaming or for presentations. In laptop mode, one monitor is used normally, while the other is used as the keyboard or control panel.
For just $67, you can make as many videos as you want.
I think that's enough, no? Okay, so what we were discussing is how computers were changed over the years, and then particularly we have seen how notebooks were changed over the years. So that's about how we could classify computers in one way. So likewise, there are many ways that you can actually classify computers. Now the next one is like you can look at the size of the computer. If you look at the size of the computer, you can classify the computers as supercomputers, mainframe computers, mini computers, and microcomputers, right? Or the supercomputers means very high performance computers, like places like NASA, places like Google, data centers. They will have this, network environment and with a lot of processors in it, which we call the supercomputers. So they basically use for very complex applications such as weather forecasting, nuclear simulations, scientific computing, and so on. And they are large in size, expensive, and very rare, right? While mainframe computers actually quite old, very traditional, very large, multiple users could, access to the machine, a little bit large compared to, mini computers. Mini is, less powerful than mainframe computers, and the number of users also very less. Microcomputers means what we have used the day-to-day life nowadays, like personal computers, most common computers. So these are the based on the size. Now let me show you a couple of things like supercomputers. So if you ask me like what is it, let's have a small video on this one.
The race for the world's fastest supercomputer is on. China held the lead for the last 5 years, but the United States has surged ahead with Summit. It's a $200 million government-funded supercomputer built for Oak Ridge National Laboratory in partnership with IBM and NVIDIA. But what is a supercomputer? Today's supercomputers are comprised of thousands of connected processors, and their speed has grown exponentially over the past few decades. The first supercomputer, released in 1964, was called the CDC 6600. It used a single processor to achieve 3 million calculations per second. While that may sound impressive, it is tens of thousands of times slower than an iPhone.
If you have a smartphone, it is more powerful than the supercomputer that we had back in 1995 doing human genome.
Today, Summit consists of over 36,000 processors from IBM and NVIDIA that can perform 200 quadrillion calculations per second.
What a typical computer will do in 30 years, this machine will do in an hour.
Summit takes up 5,600 square feet of floor space and has nearly 200 miles of cable. It uses 4,000 gallons of water per minute to stay cool and consumes enough power to run 8,000 homes. But why do we need such fast computers?
It has tangible results in terms of how it helps society at large. It will translate into better appliances, better security systems, better delivery of power, more efficient homes. Every aspect of life, it'll change.
Supercomputers are used across all sectors, forecasting weather and climate trends, simulating nuclear tests, performing pharmaceutical research, and cracking encryption keys. Summit is the first supercomputer designed for artificial intelligence applications, and researchers plan to use Summit for AI projects that could identify genetic predispositions to cancer or opioid addiction. By surpassing China, the US has escalated the tech rivalry between the two countries.
There's no question the race is on. But this is not the space race. This is the race to knowledge.
But faster supercomputers are already on the horizon. The European Union, Japan, and China are all developing machines they say will outperform Summit. The next big frontier is exascale computing. That is, computers that can perform 1 billion times 1 billion calculations per second.
The use of this machine is only going to be limited by the imagination of the scientists who will have access to this machine.
Right. So I think you have seen a supercomputer. And then mainframe computers, as I told you, like it was quite old computers. Very big computers, centralized one were used earlier. So you can see sometimes similar as what we have in supercomputers, but it was something like this in early days, right? So it was something like this in early days. Let me open up the image in new window, right? Something similar to this, right? So this was the main computers were used. As I told you, is multiple users can access it. And then mini computers. Again, quite old those days. Like this, this is one of the mini computers were used. Right, so this was how it looked like earlier. The number of users were limited compared to mainframe computers. I think microcomputers, we already know microcomputers means like what we have with us today. Right now, we discuss two main things. We discuss computer classification based on generation and based on the size. Okay, Dulina, can you tell me like how can we classify computers based on generations?
First generation computers, second generation computers.
And so on. Okay, Bhagya, how do we classify computers based on size? Supercomputers, mainframe computers, mini computers, and microcomputers. Okay. Dulina, Bhagya is not in the meeting, right?
Yeah, I guess she is left. Wait, I
Yeah, I'm sorry. I think I have explained, but I have muted my mic. You haven't seen it, right? Sorry, guys. Where we have stopped last time?
We just finished the first unit.
Design technology.
And we discussed up to mini computers.
Right. Okay. So the next classification is based on the digital design technology. So in design technologies, we can classify as digital computers, analog computers, and hybrid computers. Now, what we use today, mostly digital signals, when we have two levels of signals. In mathematically, we can represent as 0 and 1. So those are called digital signals. So most of the computers that we will use comes under digital computers. Then we also have analog computers. Now, if you take temperature, you know, changes from different levels. It's not only just, two levels. Like temperature varies, pressure varies, speed varies. So if you use this kind of a physical measurements in computers, we call analog computers, right? And then the hybrid computer actually combine these two technologies together. That means in hybrid computers, it uses both digital computer, digital signal as well as analog signals. Now, if you take ECG machines use both digital as well as analog signals. Right. And finally, we can also look at other classifications like we will have desktop computers or PCs. Their capabilities slightly different from what we have used the others. And then laptop computers, notebook computers, and palm top computers. Those are portable and all in one, everything in one single case. And then we have new edition tablet computers. We have computers with a touch screen. That is another way of classifying computers. And then we have more powerful computers like, if the computer is more capable when you compare to a normal machine, then we used to call it workstation machine. So usually you will need special hardware enhancement for workstation computers. And the next one is the last one is called server computers. Now, for example, if you connect to the internet, we are connecting to a special computers, web servers to access web pages. So likewise, if you take email server like Gmail, right, in there we will actually connect to the Gmail email server and then we'll access the our email service. So those computers which will serve different services we call server computers, right? So with that one, actually we conclude the ways of classifying computers. So before we move on to the next one, I would like to ask few couple of things. Bhagya and Dulina, can you tell me like what are the ways that we have discussed of classifying computers?
Based on its size.
Yes, one is Dulina said based on size. Bhagya? Technological development, yes. What else, Dulina?
Characteristics of computers.
Yes, we have depend on what technologies were used, like whether digital, analog, or both. Right. So with that one, we will finish that part, and the next one we are going to look at more inside of the computer now. So far, what we have discussed in generally about the ICT and as well as computers. Now we are going to look inside the computer. So let's start with the fundamentals of computer systems. So when you say a computer, right, we know that it's a electronic device, isn't it? When we say computer, it's an electronic device, right? Um, Right. So let's start by looking at what computing is, right? When you look at the computers, what is computing, right? What is how are we going to classify computers? So a small question from both of you. Can you give me an answer, right, for what is computer? Yes, Dulina? Bhagya? What is a computer?
A system that contains hardware and software.
Okay. A system which contains hardware and software. Okay. Bhagya?
Processes and gives an output.
Can you repeat again?
Processes and gives an output.
Okay, process and gives an output. Yes, okay. So we have input, process, and output. Yes, that is another way. And it also electronic device, isn't it? So when you say a computer, it's like any other electronic device. So you can simply say computer is a electronic device, but it can take input, process it, output it, or you can even store, right? You can store, right? So all these capabilities are there. And as Dulina said, it consists of Unisekers as a computer system. You will have both hardware and software. Good. Right. Now let's look at the difference between the computers and humans. Now let's say we have computer and then we have humans, right? So sometimes we have discussed instead of humans, we are using computers. Why? Right? The question is, what is the difference? Computers and humans. Dorina? If you compare computer with human, what are the difference you will see?
Computers are more accurate.
Okay, let's say more accurate. Okay, and humans are less accurate, is it?
Yeah.
Okay. Bhagya?
Multitask.
Okay, computer can perform, yes, it's multitasking. Yes, exactly. Bhagya, can't we, have, perform multitasking? Like, while we are eating, we watch a movie, or like we listen to radio while we study. Multitasking, isn't it? What do you think? But computers are more capable than human, isn't it? We might be able to do one or two things together, but computers can do multiple things, right? So they are better than doing multitasking. Yes, I agree. Delina, anything else?
Computers are speed.
Yes, the speed. Yes, we can say, for example, computers speed is high. We can say here speed is low. Yes, good. Bhagya?
never gets tired.
Okay, never gets tired. Yes, computer can works for, you can say, okay, never gets tired. Computers can works for, we call 25 of 7. What do you mean by 24 by 7?
24 hours. Throughout.
Yes, yes, exactly. Computers can work for 24 hours, 7 days per week, which means like whole year, right? Without taking any, any break. Whereas we need a lot of breaks, we get tired, like you feel hungry, for example, like we are getting hungry, we are exhausted, we need tea breaks, lunch breaks, like all sort of everything, right? But when it comes to computers, it's not like that. So that's actually more advantage, like, oh, the positive aspect of computers. But it's still, that we can't replace humans. Why? Still, we are better at doing some other tasks when you compare to computers. What are those?
Humans can adapt to the nature. Uh,
Yes, you can adapt to the nature, adapt to the situation, which means we are intelligent, isn't it? Computers, are they intelligent? Can we have some intelligence in computers as well? Yes, Bhagya, what do you think? Yes, Dulina?
in a way, they have an intelligence too.
But it's artificial, right? Remember, we will say AI or artificial intelligence. Yes, machines, you don't have real intelligence, but what we could create is artificial intelligence. So that's why we call it artificial intelligence there. Machines, it's not real intelligence. Human has to craft in a way that computer can perform task intelligently, right? So that's why we call artificial intelligence. When you compare the humans, how about the feelings? When you take humans, we have feelings, right? But when it comes to computers, no feelings are there. So when you actually work as person, so sometimes you need to know the feelings as well. So whereas we cannot give this particular skill to computers, right? So that's the simple comparison that we make to see that what we have. Okay, the next thing that we are going to discuss is basic functions, right? The next thing that I would like to discuss is basic functions of a computer system. Now when you take computer as a system, right, when you talk about the basic functions of computers, we can discuss a couple of things, right? For example, we can talk about the inputs, the process, the output and storage, right? Now when you say input, right, let's say we have input. Now here what we mean by input is necessary data and instruction, right? Then process, you basically convert data into information. Output, that means you get the results out of this. And finally you can have store, right? You can store information inside the computer. So those are the basic ones. And finally what we have is control. So the final one is you need to have control. So those are the basic functions of a computer's system. Right, now when you look at this input, process and output, we can do a couple of things. Now for example, we talk about this input, output and process. So let me remove this, and then let's draw the input. We have input, and then we have process, and then we have output, right? So this is, we call input, and this is output, and then this will be the process. So this is how system works. So when you take so input, and then it perform the process, and then you go to the output. So this is how the computer system works. But when we talk about the process, right, when you talk about the process, processing happens in what we call the central processing unit. But before that you have to take it to memory. So let's focus more on the middle part of this, which means first of all, whenever you input something, you will get it into primary memory, right? So we are going to get it to the primary memory. So let me put this as a primary memory, right? And then we have a central processing unit for the processing, right? So here what we have is a primary memory or RAM. Let's say, for example, you are going to add 3 plus 2. So that means first of all, you have to get it to the primary memory. Now then, all the processing happens here. It's called central processing unit, or we call CPU. So this is called CPU. But in CPU, you have 3 parts, right? So we will have one, we call it memory registers, the small memories, and then you have arithmetic and logic unit. Finally, you have control unit. So you have 3 parts inside the CPU, right? The first one is memory registers, small memory locations. Right? Then we have arithmetic and logic unit. We call ALU. So whenever you want to perform calculation or comparison, it should come here. And finally, we have control unit, that you have to control this. We have control unit like this. Okay. So whenever something comes in, let's say you are going to add 2 plus 3, right? You are going to get 2 plus 3. So it should come to primary memory, and then it should go to the memory registers. And from memory register, it should go to arithmetic and logic unit. Perform the calculation here, and it should send back the results back to registers, back to memory. and let's say you are displaying the answer, you have to go back, right? And sometimes you want to, save this. Yes, you perform the calculation, you have to save. Now to save, you have to, use secondary memory or secondary storage. Let's say secondary memory. And then if you want to save it, then actually you can go from primary memory to secondary memory and secondary memory to primary memory. So you can go on save like this. So what we have seen here is how data flows. So this slide actually represent how data flows. So data and instruction flows. Instruction flow. Now you know that I have discussed about the pattern here, right? What do you mean by pattern? So I was discussing how the classification, calculations happen if you put like 2 plus 3. So if you put 2 plus 3, so that should come here first of all, primary memory, and then you put it here 2 plus 3, memory registers ALU, performs the calculation, you get the answer 5, and then back into main memory, and then depend on that output, we can put it in the output or monitor, right? So this is how it works. Now this flow actually should control from the control unit. Now to control this, we can use the control unit controls everything. Now for example here, so it can control the input. So it control the input, so the control unit. And then it can control the storage, second storage as well. Yes, so we will come here and then you can control this one. Yes, second memory like this. Controlling actually controls how the data instruction flows. And it can control the other parts of this as well. Now, for example, here, yes, arithmetic and logic unit. So control unit can, control arithmetic and logic unit. And then it can control memory registers. Somewhere here, it will control memory registers, right? And then it also, control primary memory. So we can have primary memory. Right, and then it will also control the output. This is how control unit controls the other parts of this, right? Right. So this is actually control signals. So what we had was control signals. Yes, control signals. So this is in blue color. What we have seen is control signals. Right, and this is what will happen inside the computer. So what I explain here is how things actually work within the computer. So we have input, we have output, and whenever you input something goes to the primary memory, and if it is some kind of a calculation, it goes inside the CPU through memory registers to the ALU, and you get the result back, right? And then you can store if you want, or you can output it, right? So that's how it works. I will share the note with you so that you can go through this. Right, I think this is enough for today. I will send you the note with you, and please make sure you spend some time on take down the notes, because it needs, then only you will grasp the ideas that we have discussed, right? In your case, I'm not going to spend time on giving you the notes, but I will send you the notes so that you can take down, and please go through them and come. We can have a discussion in next week. Hari Putih, Dulina මොන හරි අහන්න තියනවද? Anything that you want to clarify?